Hi, this is Professor Serge Lassert, and I wanted to give you a quick glimpse into a systems approach to gain insights into the complex dynamics of a market. Specifically, we will discuss the following: the linkages between forecasting techniques, the interdependencies between the forecast horizons, the data sources, and the purpose of each forecast. Construct a forecasting system that can provide insights into the dynamics of a market. First, to get started, let's review the characteristics of analysis and synthesis. Analysis is the breakdown of a system into individual parts. This is also called the reductionist approach, and this method works very well for parts that have low level of interdependencies and interconnectivity. In other words, this is the process when one looks at the static properties of each part. Synthesis, on the other hand, is the understanding of a system through context and relationship of individual parts within the whole of which it is part of. It is a good approach when we see a high level of interdependencies and interconnectivity between parts of a system. In simple terms, in analysis we look at the trees, and in synthesis we examine the forest. Let me start by asking a question: how do we explore? If you move to a new city, for example, you might learn the territory by walking around, or you might just look at a map. But far more effective than either one of them is to do both of them together: a street-level experience with higher-level guidance. An example of a system approach that we probably were not aware of that we do every day is exactly that: it's explore a city through a map. And this works simply because the most powerful way to gain insights into a system is by moving between levels of abstractions. Here are a couple of additional examples. An economist gains insights into the gross national product by moving between levels of abstractions and performing analysis of different industries or companies. Likewise, a marketing analyst gains insight into the dynamics of competitive landscape by moving between levels of abstractions and performing market share and customer analytics. We are now in a position to discuss the interdependencies and connections between each level of a forecast horizon and a typical product hierarchy that one sees in several companies. There is an interdependency and interconnectivity between a corporate or product structure hierarchy and levels of abstraction when constructing a forecast. This linkage comes with respect to forecast horizon and the level of the hierarchy. It is important to select the correct level of abstraction in the hierarchy to develop the desired level of forecast and its respective horizon. Finally, the drivers of abstraction are the hierarchy itself, the breadth of the product mix or the width, and the depth of each product line or the length. Looking at each specific forecast horizon, the short-term forecast, which drives resource flexibility, uses point-of-sales data as a major driver. The medium-term forecast drives supply and demand matching, and it is an input to the sales and operations planning process. Finally, the long-term forecast is the basis for strategic initiatives such as investments into technology and capacity. In turn, each forecast is constructed using specific tools determined by the purpose of the forecast, the types of inputs, and the necessary level of abstraction. The short-term forecast typically uses ARIMA types of forecasting models. Medium-term and long-term forecast can use sophisticated exponential smoothing models or assumptive models. As the level of abstraction increases, forecasting models become more and more assumptive in nature. Understanding markets for bottled water, for example, is a complex systems problem. By developing a forecasting system with the right level of abstraction, one can gain insights into trajectory, inflection point, landing point, and finally, transition points.